Hey, everybody. Hey. I'm not going to do that thing where I make y'all say it again. Hey, everybody. Okay. Hey, so I'm Jonathan Dagerhart, and this is Drupal 8 Developer Training, essential Drupal 8 Developer Training. And what I'm wanting to do with this with this training today is basically ramp you up from sort of maybe a beginner level developer as far as like with Drupal 7 or WordPress or something like that to an object-oriented developer, and then how to use those concepts in Drupal 8. So the first thing I'm going to do is get a sense of where everybody's at, maybe ask people to move around just depending on your current setup, and I'm going to hope to sort of on the fly tailor my explanations to what might best sort of relay the concept to where everyone is. So I'm going to start by asking a few questions like, how many people in here have ever written code for Drupal before? Okay. And how many have written code for another system that's not Drupal? Excellent. Okay. And WordPress? All right. And let's just see, JavaScript? Any? Okay. All right. Yeah. Okay, so who here has a working local PHP site on their computer? So you could write a function and you can run it. Okay. Actually, will you leave your hands up if you have one working locally? So if you do not, I would recommend maybe moving to beside someone with their hand up right now. I can sort of point you towards people who, I can point you towards like a very simple way you can get one going, but I'm not going to have time to walk to every single person and get them set up. It's not completely necessary, but what I hope to do is I'm going to have a number of slideshows. We're going to introduce some concepts, and I'm going to say, okay, now everybody try it. And that would be a good time to, at the very least, be beside someone who can try it and maybe share computers. If you want to try to set up a local environment and you don't have one yet, I would recommend MAMP, and maybe Sean can help you if you want to download MAMP, M-A-M-P, and install it. But basically, if it seems like everybody's coded something before, so the concept should come across. And if you don't want to set up a local environment, I just recommend moving next to someone who can try it out. And we'll have time in between sections to sort of relax and try things. And Q&A. So what we're going to cover is we're going to talk about object-oriented programming conceptually from the very beginning, just sort of syntax, concepts, and what you need to understand about why object-oriented is a thing and how it's valuable. After that, we're going to look at what is called auto-loading, which is a concept that helps object-oriented systems in the background, and I'll explain why that's valuable. And then we're going to start moving towards Symfony and Drupal, and then we'll get into Drupal. So that's going to be throughout the whole day, and ideally by the end of it, we're at a section where you're creating custom blocks in Drupal 8, and you understand how it works. Maybe, and hopefully everybody has a chance to try it on their local computer. But if not, at the very least, then maybe that understanding will get through. We'll see. So any questions before I begin, or does anybody want to move and shift next to someone else who has a working local? It's okay. Working locals, raise your hand. And if you want to try to set up MAP, and you want to, and if Sean can help you, if you want to try to set one up.
I'm Sean. I'm back here. Need help?
Yeah. So if you're working on something throughout this, and you need help, just raise your hand, and Sean will come by. All right. So here we go. We're going to do Introduction to Object-Oriented Programming. And hi, I'm Jonathan Dagerhart. I'm recently a developer at Hook 42, which is a Drupal company in San Francisco. Started working there just a few weeks ago. And here's some information. This is my vanity slide. It's got a young picture of me and some links to myself and to Drupal Asheville. Feel free to tweet or whatever if that's your thing. And hopefully the rest of my vanity slides, I broke this up into 7 different slideshows. Hopefully you don't have to see this slide 7 times, but we'll see. All right, so getting started. With object-oriented programming, what I want to get across is a lot of the vocabulary, the words we're going to talk about, the words that represent concepts. And often these words are very fancy words for relatively simple ideas. And what I hope to get across is the understanding of those ideas. So the concepts we're going to talk about are classes, objects, encapsulation, don't worry, fancy word, inheritance, interfaces, and also abstraction, which another fancy word, which I will explain. And importantly, the syntax for when you actually start writing object-oriented code itself. And we're going to do this, but we're going to take a journey, getting to objects, a story of encapsulation and abstraction. So the goal of this section is we're going to go from a calculation to a calculator, and this is moving from a business calculation, which is just writing code that processes numbers, to an object concept, which is a calculator that is reusable. So here we have just a really simple common business problem. We need to calculate some value, and this operation has to be performed at some point in the system. And what we have here is we're just doing some math. This is a very complicated business problem, you can tell. And so what I want to do is I'm going to take this and I'm going to apply the concepts of abstraction and encapsulation a number of times until we get into an object, which is going to be a very reusable, valuable class that's much more valuable to your system. So we're going to start by, let's talk about what is abstraction. Abstraction, a fancy word, and what it means is to make something more generic and therefore more reusable. So I'm going to throw the word abstraction around a lot, and I just want you to understand that it means to make something more generic. And often the way that's done is by modifying something to a function or to a class that accepts parameters, because that's what makes it more generic. So here we have at the top just the word total equal 1 plus 3, which is not reusable. Like, sure, we have the number 4, we've got this calculation, and it works in that one spot. But what we can do is we can make a function that adds any 2 numbers, and now we have something that's incredibly reusable to the system. We've abstracted this concept of a single calculation into a thing that can perform calculations for us. So that's abstraction. Encapsulation is when we wrap related functionality together. And yes, so the idea here is that we take something like our big business problem from the first slide, and we wrap it all up together into one function that's probably called calculate business number. And now since we have it all wrapped together, we can actually do it a number of times throughout the system. So no longer do we just have one simple math business problem happening at one point in the application, but we've encapsulated into a function that's reusable. So the difference here, I suppose, is that this encapsulation is wrapping multiple things together that are related, and the abstraction is just showing making something more generic. Any questions here? Because we're about to move to objects, okay? So the first thing I want to do is I want to take our common business problem and I want to encapsulate it. So what we've just had is we had a bunch of math randomly sitting in our application, and I'm going to wrap it up together so that it's related functionality into a function called calculation. So here I have encapsulated our business problem, and now I can run it as many times as I want throughout the application. Say it's needed when someone visits one page and when they check out on their cart. Now I don't have to retype this code over and over and over again. I just run this function called calculation. So step one, we've got our business problem. Now let's wrap it all together into a thing. And we've encapsulated it. We've made it more reusable. So then what I want to do is I want to abstract this a little bit. So before, if you notice, this calculation can only ever produce the number 18. And that's very useful. That's useful when the result we need is the same all the time. But what would make this function much more usable is if we add an abstraction to it, which is a parameter where we can change the starting number that the business problem begins working on. So now our fancy calculation can not only produce the number 18, but it can perform that same calculation on any starting number. So we've abstracted just a little bit. We've made this business problem reusable and more valuable. Let's go another step. Let's abstract a little further. So instead of just all of these little things being done here in this one function, let's break it up. Let's abstract every single line of that function out into its own functions, to where we now have not just one addition and subtraction, but we've written these common functions that are reusable throughout the whole system many, many times. So now our business calculation is still doing its job, but we've added value to the system by taking this generic addition of 1 plus 2 and saying, like, actually, let's write a function called add, and now we can do that whenever we want. I know this is an overly simplified example because modifying numbers in programming is a part of the base of programming. But you see, like now our calculation is made up of all our abstractions, and our abstractions can be used throughout the system over and over again. So we've made this business problem, we haven't made this specific calculation more valuable, but we've added value to the system by abstracting out the concepts of what are happening within that calculation. Now, if we go one more step further, we're going to encapsulate one more time. So what we've done is we've wrapped up our calculation, we've broken it out into tiny little pieces of value. We're going to wrap all those broken parts out one more time. And if we encapsulate all of these functions into a new concept, then we can reach a class. And this class is our first step towards an object-oriented system. This class is no longer a calculation, but it's an encalculator. Because what we can do is we can create instances of this class and reuse it over. We can use those objects over and over throughout the system. We can pass those objects around. We now have we are now towards the end of our road of getting to objects. And we're going to take a step and talk about the vocabulary a little more. So here we are. We have a class, which is just like writing a function. On its own, it does nothing. But then we can use that class, and by doing so, we have an object. So this is just a little bit of vocabulary. The class is like a template for an object. And when you start using it, what you're using, we call an object. And we'll talk a little bit more about that. So here we are. This is our calculator. We've gone from a simple business calculation to a generic object that's had much more value and reusability for the system. So a class is a template for an object. A class can have variables within the top level, and those are called, when they're inside of a class, they're called a property. So just know that if you hear the word property, that means a variable within a class. A class can have functions inside of itself, and when functions are in a class, we call them a method. So these are words, properties, and method that you might have heard before and are completely and maybe a little unclear on. Just know that these are the exact same concepts of a variable and a function They just exist within a class. And visibility is represented here. So when we write a class, we can actually define what has access to all these little different parts, and that's called visibility. So by default, everything is public, and I've actually written the word public here, and that means that anything that uses this class has access to this property. Yes?
Are we going to get copies of these? We want to give
Oh, yeah. Yeah, y'all can have all the slides you want, and I even have a GitHub repo with better examples in it that I'll share. Once we go through this show, I'm going to stop, and I'm going to, and we're basically just going to sort of Q&A, talk about it, try some stuff out, and y'all are welcome to copies to all of this. So some other visibility words are private and protected, and just know that you're going to see these words in classes throughout your object-oriented career. So a private function means that some other part of the system cannot use that function, cannot use that method. Now there's one other piece of important syntax to be aware of, and that's this keyword here called this. When we are inside of a class, when we are working within a method inside of a class, the word this means this class. So here, when the method add modifies this total, it means that it's changing the number here. It's changing the value total that is within this class. And a little more vocabulary and syntax just to be aware of, because these words are going to come up a lot. So an object is an instance of a class. Since a class is a template, if we make one of those things from a template, we call that instance. And you're going to hear the word or see the word instance a lot. So an instance is the noun form of that word, which is the concrete occurrence of it, synonymous with the word object. And to make one of these, the verb of it is called to instantiate. So if you have a class that you want to make an object out of, you instantiate that class, and you do so like this. You say, new calculator is equal to this thing. So here we are instantiating the calculator class, and the result of that is an object that I have chosen to name calculator. And the other bit of syntax is, now that we have this object, how do we access properties and methods on it? We use dash greater than, which is little arrow. And so we say the object's name, whatever the variable you named it. So the calculator dash greater than, and then we can access a method or a property. So this is the syntax that we're going to get pretty comfortable with by the end of the day. Any questions so far? Is anybody, anything not clicking, or anybody feel like they need to write their own class to make this really stick? Because we can pause here. All right. So here's a little bit of a review. Here's the class. It's a template. And then when we instantiate it, we have an object. I guess this is the slide where I was supposed to ask if you have any questions. I did it one early. Yes?
But I don't have a question, but in case there's anybody here who's wrapping their head around this, one thing that helped me was picturing the class to be like a set of blueprints.
Yeah.
And the instance would be like hiring a builder to build the house for you, and the house would be the object.
Yeah.
So it's just kind of a way of thinking so that when you throw those words around, you get comfortable with it.
Absolutely. Yeah, that's a great analogy. Yes?
So what do we call this operator? It's the dash and greater this total?
Yes. No, I believe it probably has a technical name that's probably like an accessor or something like that. I call it little arrow. But it's I bet it has a name, and I feel like I'm going to guess here that it's called an accessor. So the arrow is what lets you access parts of the object itself. Does anybody know differently what the concept behind little arrow is called?
It points into the object.
Yeah. Yeah.
Gotcha.
Yeah.
That's what's
Okay.
Nobody ever uses it that I know.
Right.
We all say
That's fine.
Right. Yeah.
Thingy peppers.
Absolutely.
It's an
Oh.
Indian name nobody can pronounce.
Yeah. It's I feel like I've heard it once, but only academically and never talking programmer to programmer.
Okay.
Yes.
So when you name that new calculator, it can be anything.
Yes. Any class that's in the system, I can instantiate by saying new class name. All right. So we're going to talk about inheritance a little bit, which is another step along our object-oriented journey. And inheritance is an abstraction. It's the concept of creating multiple types of a class, subtyping of classes. And what that means is we can take an existing class that's in the system and we can make a minor subtype of that or a major subtype of that. Sorry, I shouldn't have used the word minor or major because those aren't technical words. I just mean we can make another type of that class easily by inheriting all of the properties and methods that are on that class. And we do that by using similar syntax for defining a new class, but we say that our new class extends the calculator. So what I want to do here as an example is I want a calculator that never returns a fraction or a decimal. And so I'm going to create a new subtype called a whole number calculator. And I'm going to say class whole number calculator extends our original calculator class. Now our whole number calculator, if I hadn't written anything right here, our whole number calculator has all the same, has add, subtract, divide, multiply, total, has all the same properties and methods of the other class. But within our whole number calculator, we can add whole new methods, and we can override existing methods that are on that other class. So, for example, so for this example to work, the whole number calculator needs to override the divide method, and it needs to make sure that it never results in a decimal. And so all I do on this whole number calculator is I define the divide method again. And I tell it to this, I could have done this less complicated. I tell it to go ahead and divide as the parent class does. So I run the parent's divide method on that number. But then, after that's done, I round off the total. That way, if I go 10 divided by 3, I'm going to result in the number 3, as opposed to 3.333333 in this whole number calculator. But also, I can add a whole new method that doesn't exist on the calculator, and I created one just called isOdd. Is the total number odd or even? It's not or even, it's just a true or false, is it odd? But this is just an example of how you can take something that already exists within the system and you can create your own subtype of that thing. And this concept is called inheritance. And that's another one of those words that's just, I feel like, when I was first sort of learning object-oriented, you hear inheritance and it sounds a little intimidating. But it's really not. And now I feel like the more you learn and the more you demystify the words, all it means is creating another version, a subtype of an existing class. So the syntax we need to worry about here is the keyword extends, which is how we do this conceptually, how we inherit another class, and parent colon, and here we have a different accessor. So parent means the calculator class, and colon is how we access something statically. So we're calling the parent's divide method. And that's probably a little more complicated syntax than it needed to be. But
Could an analogy be opening a new browser tab and all the bookmarks?
that could work. It's browser tabs are a little complicated because it's kind of more like forking. It's I think I think if we get really literal with the word, like where does the concept of inheritance come from in nature, and we're talking about a mama bear and baby bear, then the baby bear is going to have most of the properties and traits, like 99.99999% is going to be exactly like the mama bear. But it's going to have its own unique stuff as well. So if you think about inheriting from a biological level, I think that's very valuable. As far as other analogies, you can think of it as, so if we went back to the blueprint, so if a class is a blueprint, then inheriting off that class is when you're hired to design a new house, and you're like, I'm going to start by copying my old blueprint, and I'm going to add this extra room they want. So I'm not sure if that's helpful, but there it is. Yes?
While you're on that topic, I want to wrap my brain around something too.
Sure.
Okay, so since we're copying the old blueprint,
Yes.
which in itself is not an object, but
Right.
a class, right? Is that why we're using the static pointer?
Yes.
Because it's not an object, so we have to use the static inheritance.
Exactly. So yes. So this so the calculator isn't an instance. It's not an object. It's just the template. And so to access from within our child, I suppose our child class, to access its parent without it being an instance, we use this accessor. The keyword is parent, which it just knows. It's like this. This is the keyword that means whole calculator. Parent is the keyword that means the class that this is inheriting. And the colon is an accessor that means to access it statically. And to talk about statically, we got to talk about how computers work. But basically, it's saying go and get the calculator classes divide method. Not some specific object, not an instance of that class, but the calculator template itself's divide method. We're getting into the weeds with some of that, which is like, I may want to drop that example specifically from inheritance. But yes, the reason this is different, the reason parent : is different from this is because we don't actually have an instance of a calculator when we're defining this class.
It was actually good that you clarified that. That was helpful.
Okay, awesome. Yes, I'm going to go moving on, and there'll be time. So anytime you got a question, let's talk about it, because I think we got 7 hours to fill today. So here we are with an example. And I think I even already spoiled my example, but we've got our child class over here. And now we instantiate it the same way we did our other calculator, but we call it by name. So our object is a new whole number calculator. We can add 10, which notice I haven't defined the word add here, and so therefore it's calling the calculator's add method. We add 10 to 0, then we divide by 3, and we print out that total, and since that number was rounded off, our result would be the number 3. So here's another example of inheritance, and people really like, if you look this up online, people love analogies that involve animals and vehicles. Man, how many car examples have you seen, or bicycles or whatever? And I'm not a super fan, but I thought like maybe this will help. So let's start with this just generic class called an animal. And all animals have a number of legs, maybe, and they make a noise, or they have sort of a baseline noise. Let's just ignore that. And then, when they make that noise, we're going to say that they do it with their voice. So they have a method called vocalize. So now I've made two different types. I've inherited the animal class twice. Once in a Labrador, and I've said that a Labrador has 4 legs, and its noise is bark. And I have a parrot, which has 8 legs. Oh yeah, I meant to fix this. I started with spider. So let's just say, for the sake of this example, parrots have 8 legs.
This is how it would go if Motion were true.
Yeah. And the noise they make is the default noise they make is chirp. But parrots have overridden the vocalize method, and I've let it accept a whole new words that you can provide it. So that in my example, if I make an instance of a Labrador called Bandit, when Bandit vocalizes, it says bark! Exclamation. And I'll make an instance of the parrot named Polly, and when Polly vocalizes, I say, Polly want a cracker? And it repeats back to me, Polly want a cracker, chirp. Because I've overridden on the parrot class the vocalize method. So here's just another example of the same idea of inheritance using animals. If we really want to go, if y'all want to see vehicles, I can write one up. But I haven't found vehicles to help me at all. Any question here? I mean, besides the number of legs parrots may or may not have. Science has yet to tell us for sure how many legs parrots have. All right. Yeah, yeah. Or does a spider chirp? All right. Okay. So, last chance for questions here. I mean, I'm trying to keep this real simple, and we're going to see that once we get, probably after lunch, once we get into Drupal, we're going to be using these concepts a lot, and I hope that they feel simple by that time. Yes?
So on a parent class, if the method is protected or private, can the child class access that?
No. So if it's private, the child class. Do you know? Yes.
Yeah, I'm pretty sure. It's been a while since I dealt with it, but if it's private, the child class cannot. If it's protected, the child class can.
Right. Yeah.
It's kind of like the child class can work with the protected, but it's still private to everyone else.
Right.
It's kind of
Yeah.
like a family thing.
That makes sense. I was pretty sure the private was not, but I hadn't gone through protected recently. Yeah. Good question that I should add as an example for this slide. Okay, interfaces. Here's another concept. Big, complicated concept with a big, fancy word that I'm going to hope to try to demystify in about 2 or 3 slides. So an interface is, if a class is a template or blueprint for an object, then an interface is an abstraction that is a blueprint for a class. So there's the short of it. And let's see what this looks like. So a common analogy for an interface is it is a contract that a class chooses to accept, which defines strictly what methods a class must have on it. So, for example, if I have an interface, which I define with just the keyword interface, named dog, and I say within this interface that the dog must have a public function named bark that accepts no parameters. That means that any class that makes use of this interface must have a public function named bark, or your app will fail. It'll just crash. It is a very strict contract between a class and a set of expectations. So interfaces, so some more sort of technical details here. Interfaces can define methods. They can't define properties. And that's why you'll see certain patterns in object-oriented programming with getters and setters to sort of make use of interfaces and keep things reliable. The syntax we have to deal here with is the word interface. Boom, that's how we define a new one. And notice that methods don't have braces and they don't have anything in it at all. It's merely defining a signature that the class must adhere to. So it is just visibility, function name, parameters, semicolon, you're done. You write no code inside of an interface. So let's see this in practice. So when a class wants to make use of an interface, it uses the keyword implements. So here we've defined that same interface. Interface dog has the public function bark. I'm saying that this class Labrador implements the interface dog. That means my class, I must write this function in it. Otherwise, the app will crash, fatal error, because it's a strict contract. Saying that Labrador implements dog says that Labrador signs the contract that dog demands of it. Really pushing this contract analogy. So something else that's great about, so here's something that's great about interfaces. Oh, there's a lot of great things about interfaces. But one thing to know, sort of in a step back, is when you're defining a child class through inheritance, you can only ever extend one class. So using inheritance, you can only inherit one thing. But using interfaces, you can implement as many interfaces as you want, practically speaking. So that means that we can have many different interfaces that all defines a bit of functionality. And our class can implement all of those. And now that class has become extremely reliable to the greater system. We can mix them together, but I probably should have shown a better example. Yeah, actually, let's go here. And then I'll take a step back. So here's our old example of inheritance, where we've created a Labrador class that inherits an animal, that extends the animal class, and a parrot with 8 legs. So if I were to refactor this concept from inheritance to interfaces, here's what it would look like. So since interfaces cannot define properties, I have to sort of change this concept here from a legs property to a method that we'll call getLegs. And since I can't define a noise property, I'll say getNoise. Same idea. So these are just sort of moving our brains into an interface world. So the animal interface has legs and noise changed to methods. The dog interface implements bark. And now our new class, Labrador, implements both an animal and a dog. And therefore it must define getLegs, must define getNoise, and must define bark. So I got a little, not very, but just a little fancy with it. So now whenever this dog barks, it barks 3 times. I don't know why. But, so let me take a step back now. Actually, leave this here for a second. These examples could be more equivalent. They're not exactly. I could do better examples here, so shame on me. But are there any questions here between sort of how this is what inheritance looks like, and this is what using interfaces look like? Okay. Well, yes.
So can you put you on the spot a little bit?
Sure.
Can you kind of give like some real world pros and cons versus using one or the other?
Yeah. Absolutely.
Like some pitfalls with using inheritance and some.
Yeah. So the easiest one, since I am on the spot, is the pro that I've already listed for interfaces that's right above me, is that we can implement as many as we want. Whereas with inheritance, we can only extend one thing. We can go deeper, and we can say class red parrot extends parrot, which naturally extends without me having to say so, animal. But the difference, I guess, is in the concept of inheritance versus, what's the word? It's a C word.
Oh, composition.
Composition. Thank you. Do you know the answer to this question already?
No,
Okay.
I've started hearing the debate between inheritance
Yes.
and composition, and I thought this was
Yes.
getting at that. But
Absolutely.
I wasn't sure.
Yeah. So it would be tough for me to come up on the top of my head a perfect example explaining the cons to too much inheritance. But basically, just sort of imagine a very complicated system in which you're writing a new extension to that system, be it a plugin or a module or whatever. And what the system sends to you is a blue parrot. And you're like, well, but blue parrots, blue parrots aren't exactly what I need because, see, I'm getting down in the weeds. Okay, so every time, let me step back and say inheritance versus composition. Okay, so every time you make a new subtype of a thing, you're more and more tightly coupling the system to every single piece of that thing. So if you can imagine a very, very inherited class where it extends something that it has extended something else that has extended something else, then now we've created a system to where possibly a dozen things are completely necessary for the system to work. They're tightly coupled. And it's very hard to swap those things out because the system might be, we've inherited 8 things. The system might be programmed way over here to expect something this middle one does. And so to swap that out or to debug that is very difficult because the system has become tightly coupled to all of its pieces. Whereas instead, if we're using 8 different interfaces, so now we're not this deep in inheritance, but actually we're about like here. We've got one thing that inherits, that implements 8 other things. Each of those 8 pieces are very easily swapped out, and they're very easily debugged. And since we have a smaller hierarchy, we have less coupling, looser coupling rather. Does that make sense?
Yeah.
Okay.
Yeah.
Yeah. Yes. Yeah. For a very simple analogy, yeah. Inheritance is building a house of cards. They're building a very tall house of cards. So if you want to swap one out on the bottom, good luck. Whereas interfaces is like building a single row of cards, just a whole bunch of little pyramids of cards. So if you need to swap just one out, that's no problem. That's not going to collapse the whole system. Yes.
Kind of going back to your example of a blueprint in a house
Yeah.
you built, and now you want to build another house, and you want it to be just like this house with a few differences. Right?
Yeah.
So if there wasn't the interface of, for example, the requirement that all wall sockets that are for 120 volts must be of the prong configuration, right?
Right.
Let's say you just left it up to the electrician, and some of them use duct tape, and some of them use black tape, and some of them solder, and some of them make a socket, and some of them make a different socket.
Yeah.
Well, now you're tightly coupled to, when you copy that house, you have to copy all that stuff.
Right.
But if you have the requirement or the interface that a telephone jack looks like such and so, and a 120 volts looks like this, and 220 looks like that, and you must obey that, and the inspector comes and makes sure that you obey that, or it crashes, right?
Right.
Now you can duplicate that house and make all your changes, and it's no problem. You can take away some plugs and add some plugs and put them wherever you want, and it's totally okay.
Yeah, that is a great analogy. All right, so I'm going to repeat that, and I'm going to point to it. Yeah, so an interface is specs. So it's specs that you must adhere to. So you can't see it. Picture a wall socket. Every implementation of a wall socket's not exactly the same, but the specs are these 2 slots are this big, they're this far apart, there's a small one at the bottom. Yes.
Sorry, let me add one more.
Oh, sure. No, yeah.
And because that's true, now completely unrelated businesses that don't even know you or your house can create appliances that anyone can use and plug in whenever they want to because of that.
Yes.
Because of that
Specification.
known specification.
Yeah.
And so that opens up huge possibilities, whereas if that were not true, you have to know the guy and ask him how he soldered it or something.
Right. Like how far apart did you put the holes in your wall sockets on this house? Yeah.
So when we say coupling, we're talking about that restriction that forces us to have to deal with a whole bunch of junk that we don't want to. Decoupled means, hey, I'm some business, I don't even know you, but I can make an appliance.
Yeah. Yeah. Absolutely. Thank you. Any other questions about that? I'm going to change my analogies and examples to house specs now. Yes?
So, if the interface doesn't include any properties of the interface, what do you mean by using?
What I'm gaining is a standard. So if I say that, actually, I can show you exactly what I'm gaining in a future slide. Let's see. Okay, can I come back to that? I might have to unhide a slide that I hit, but that's getting into really like sort of an ideal goal when you're writing object-oriented programming is a concept called programming to an interface. And it involves type hinting, and it's sort of a little step outside of the training, but I'm gonna make sure to talk about that in I think 2 slides. So the question is, what do we gain, or like what do we gain by using interfaces? Like a practical example. Yeah, you gain flexibility, and I show that in a slide in just one moment. Okay, so concepts to take away. I mean, I can always jump around. This is real casual, right? Let me unhide that slide real quick. So I call this this is your goal, and it involves a concept called type hinting. So if this is brand new, I apologize. We're sort of jumping ahead, and we're going to come back a little bit. But in programming, you can, when you're writing a function or a method of some sort, you can provide, well, in PHP, you can provide this concept called type hinting, which is to say that I've written this function here, and it expects a parameter that I'm going to call a special thing within the function. But I'm providing a type hint to that parameter. I'm saying that this parameter must be an instance of something called does stuff. All right. So what we want to do is the goal. Sort of when you're writing, and this is really pie in the sky stuff. Like I don't do it all the time, and I wouldn't expect anybody to do it all the time. But this is like what you wish you could do when you're not doing as well. It's programming to an interface. So here we have an interface called does stuff, and we have a class that implements it. So the does stuff has a function called do stuff. Man, I could be better with these examples. And so we know, right? So we know that anything that implements does stuff has this method. And we don't care what happens inside of that method. We just need to know it exists. So I've got a class called something that implements that interface. And down here later in the application, which is in 7 files over and completely unrelated, I have this function that I expect an object, right? And I can do this 2 ways. I could say, I want an object, or I expect this object to be of the class something, or I could write it to say, I want it to be of the interface does stuff. Now you have that choice, and this is where you as a programmer are making the choice. And what I want to tell you to do is make the choice to expect interfaces. Because when we expect interfaces, then things can be swapped out without us caring. Like, what if something else wanted to make use of this function, and it wanted to pass in its child of something called something child. Okay, so called something else, right? And if I had programmed this function to expect something, then it is impossible for me to pass something else into it. The system breaks, fatal error. But since I wrote this function to expect does stuff, I can tell something else implements does stuff, and now I can pass a completely different object into this function. Because I have programmed the system to expect this vague contract of a thing. A method must exist, as opposed to this very specific class. And so I have written a function that's extremely loosely coupled. Does that help? Does that make sense? So this is your pie in the sky goal when you're writing stuff. Program to interfaces. So if you're writing a Drupal module or a WordPress plugin, and you're dealing with a lot of objects, and you have the option to choose between writing your function to expect a class or an interface, write it to expect an interface. Yes?
Please tell me if I'm talking too much.
No, so far so good.
Okay, so that example, what I'm seeing, and please correct me if I'm wrong, is like you could say interface wall socket, and then it specifies 120 volts, 2 prongs, whatever, right?
Yeah.
And then you could say, where it says class something, you could say class 2 gain wall socket implements wall socket, or you could have another one that says 4 gain wall socket implements wall socket.
Yes.
But if you inherited, you'd be forced to have 4 gain or 2 gain. Whereas if you use what you're saying, you could say blender wall socket, or you could say coffee maker wall socket, and you wouldn't be forced to use a 2 gain or a 4 gain. You could just use a wall socket.
Yeah, you've made it more generic. Yeah. And being more generic makes it more resilient, actually. So if you think of the concept of brittleness, like it's inflexibility that makes things brittle. Iron is brittle because it's inflexible, whereas things like rubber, you can't break it because it's just a wobbly piece of junk. Yes.
Other than documentation, is there any way to know what the results of do stuff? What is do stuff going to return? Or here down in your function, I'm expecting that special thing to have a do stuff function. If I'm going to be using that, I want to know that that's going to return an integer or an array or what it's going to return.
Yes. Yes. So I haven't written any of these examples well, but ideally, when you're defining a method, you provide a doc block at the top that says exactly what type of data will be returned. In this example, since I haven't done so, then I expect nothing to be returned. So if you think of, so sometimes I call an interface documentation for functionality. Instead of that contract analogy, I'll say an interface is what actually documents this functionality. In this example, it doesn't return anything, and I didn't provide it. But do I have a doc block anywhere? Let me wrap these up, and I'll show you the better examples I've written that didn't fit onto slides.
We
Yes.
also have to maybe identify the dependencies as well. What's going to be depending on it, what you're intending with it.
Yeah, so that's a little. So dependency is a overloaded word in programming. So if we want to talk about, let me find an example with a dependency. Here we go. So this vocalize function has a dependency of a parameter. It might be a string, probably the string. So, but all I know is that this vocalize function expects a parameter, and therefore it depends on it. So here's a better example because it doesn't have a default value. Let me go back to, here we go. Nope. Here we go. All of these methods have a dependency, which is an integer to be passed into it. Otherwise, it breaks or falls apart. I don't know what happens if you start adding strings and objects to the number 0. I assume things break. But so dependency, in one sense, can just mean what the system expects. And then we like to make big words for simple concepts in programming. So there's the concept of dependency injection, which is a really fancy way of saying expecting a parameter. So ideally, when I get, I'm going to, after I switch over to, do I have it open now? Oh, Mike can just jump right into this. So what do we have? I think we've got better classes over here that are actually define some things. Okay, so here is an example of this interface that doesn't fit on the slides, where I've actually filled in all the doc blocks and comments. And so this interface is much better because it tells the system what to expect as parameters. So get total, set total, let's go to add, and what to expect from a return value if there is one. So this interface isn't the world's best calculator interface, but I know that if I use the add method, that I need to provide an integer to it. So I say the parameter integer A is any number, which is just my description. Yeah, the bug. And I say this get total, so since interfaces can't define properties, I've switched from having that total property to telling the interface to expect methods called get total and set total. So get total will return an integer or a float. So this is just sort of a better example. This is a more fleshed out with doc blocks example of that interface. So if I'm here, in an ideal world, there's a doc block written above this do stuff method that explains, at the very least, if there's an expected return value, or if there were parameters here, what those parameters are expected to be. The slides are small. Yeah. Did that answer your question, or did I just sort of go off? Okay, great.
So you have, it's part of documentation.
Yeah, if you think about the interface as documentation for a class, then that's a fundamental part of it, providing those blocks with parameters and return value.
You document, obviously you document at the interface level, but then at the class level, would you put the same documentation on that class? Just copy it, or would it be different?
It's almost always the same, and some systems are smart enough to know about that, and some systems aren't. But in Drupal specifically, what you're going to see a lot of is a special thing that looks a little something like this. Inherit doc. And what that means is wherever I'm getting this requirement from, the documentation for this method is actually the interface's documentation. So if I were to click on this, wait, what am I doing here? Calculator. Oh yeah, this is a complicated environment I've got here, because I've got the word calculator interface defined like 15 times in different examples. But in an example of Drupal, let's just go to something like node, let's say. I'm just trying to prove that inherit doc is a real thing that matters. So node entity, there we go. Let's find us an inherit doc. Okay, so here's a system that's not broken with a whole bunch of things written twice. If I click on inherit doc, maybe it's not. Maybe it is broken. Yeah, multiple uses found. That's why it's broken. Thank you. Yes. So you don't have to copy and paste. You can use this special syntax inherit doc. Yeah. It is I'm not positive. I think it is a PHP thing. And let's just solve this because we're all here to learn. No, it's actually PHP documenter, it looks like. So it's more of a standard, but not necessarily built into PHP, the language. All right. Okay. So I'm going to wrap this up and it's basically just review. Takeaways. Okay. So everything we've talked about over the past, feels like 4 hours, is a class is a template or blueprint for a thing that is modeled by the system. An instance of a class is called an object. When you do such a thing, it's called to instantiate. Just because you'll hear these words a lot. Inheritance is when you subtype a class. And interfaces are a way to define strictly expectations for a class in a way that provides a loose coupling throughout your system. So in this final example, you can mix and match. I don't think I actually showed that. Yeah, you can mix and match. You can extend another class and implement an interface at the same time. You'll see that a lot. So just a heads up. And questions about anything at all. I mean, on topic, please. Yes.
I don't know over it, but we talk about type pinning classes and interfaces.
Oh, yeah. Yeah. So if you type hint a class, then the only thing that can ever be passed into that method or function is that one class. And so you've created a very tight coupling between your method and that one class. And everything else is impossible. If you type in an interface, then that one class could be passed into your function, or any other class that implements that interface could be passed into your function. So you've created a loose coupling. So your functions, what you're saying is, my function's only asking for exactly what it needs, which is just this one method defined by that interface. It's not saying you have to fully build a class that may be 90% unrelated to what your function wants to do with it. You really just want to make sure that method exists, and so you ask for the interface. Yes?
Okay, so to clarify in my mind, what we were just talking about answering this question is that it's better to type hint the interface rather than type hint the class, and then take the class and implement that interface.
Yes. Yes.
Okay, so that's the better way because it's
Yes.
looser.
Loosely coupled, easier to swap things out. It's better in a number of ways I probably can't list on the spot. One moment. Yes, please.
So to like take the calculator example, so it'd be like if you had an interface calculator and you had a class like base calculator and a class scientific calculator and inherited base calculator but implemented calculator,
Yes.
then that way you could use an object of the calculator interface type engine, and that object could accept either base calculator or a scientific
Exactly.
calculator. Okay.
Yes. Yes. I probably have a great example. Where I probably don't have a great example, but yes. So if did everybody catch that? That's a really great example. Good. Yes. Okay. I'll summarize. I guess I don't know why I need to. So if calculator is an interface, and you implement it with two different classes, base calculator and a different class scientific calculator, then if I type hint towards the interface, either of those two objects could be passed through, as opposed to only one can be passed into that function. Yes?
With the interface, you have to use all the methods in the interface.
Yes. Yes.
So then you might want to consider having smaller you might need to have some stuff broke out to a certain interface that you may not use.
Yes. Yes. So if you implement an interface, you must strictly implement every single method that interface describes. So take a step back, and if you're writing your own interface, I recommend writing small interfaces. A couple of methods that are related to each other. 5, 6 tops, maybe. That doesn't mean that everybody does it that way. But the smaller you keep things, the more reusable it is. So the more flexible it is. Yes?
It seems like what we're doing is building bigger things off of pre-existing things, right? So is there a way to discover what already exists so you don't have to start from scratch?
In the system, such as in Drupal, or in...
The main system, yeah. How do you go about discovering what already would be something that you would want to expand and use?
Yeah, so in that case, you're sort of getting into, like, say somebody throws an app at you and you don't know it, you've never seen it before. So, like, where do you start learning what the app can do? Is that sort of like what classes it
How
has?
you might want to use interfaces and classes that already exist and you don't have to start from scratch.
Yeah. So when I'm learning something new, I like to work small and backwards. So I'll take something I can understand quickly. So for example, um, there's a few ways to approach learning a new system. Uh, when there's standardization, like with Composer, then I sort of start in that vendor directory and say, or in the Composer file and say, like, what all is in this app? What is this app made of? What are its pieces? So that's one way. If I were thrown at a complicated new CMS, that some really complicated system, and I wanted to like get a sense of how that system was put together. So yeah, I guess that's sort of the difference in approaches. Do you want to learn about the pieces, which would be looking at sort of the dependencies, the Composer file, or do you want to learn about the glue, which puts all those pieces together? And I take different approaches just depending on the need at the time. But say somebody threw Drupal 8 at me, and I didn't know it at all. I would visit one of the pages and I would say like, okay, I can edit this page. Let me understand how that concept works. And I would go and I would see like the URL. Okay, the URL is node something edit. I'm going to go find where that thing is defined in the system, and I'm going to work from this very small point backwards up into the greater system. So like, do you want to learn about the glue or do you want to learn about the pieces? I take different approaches just depending on the need. There's probably a better way.